Hi, good morning. Welcome, everyone, and thank you so much for joining us today. We are excited to have Brad Porter, Chief Technology Officer of Knowledge Lake, with us to explore the revolutionary impact of AI-driven agentic labor on the modern workforce. Brad is going to share some valuable insights on how this technology is transforming business operations, boosting productivity, and complementing human labor to drive business success. So before we begin, just a couple of housekeeping items. We are recording this webinar, so it will be available for viewing later on demand. And we do encourage your participation. So if you have any questions throughout the presentation today, please type them into the question window in the Bright Talk panel, and we will address those during the Q&A session. So with that, we'll kick things off, and I will pass it over to you, Brad.
Thanks, Rachel. Hi, everybody. Good morning. I have my LinkedIn profile link on here. Feel free to ask questions as we go in the chat on the right bar, as Rachel indicated. We have a Q&A carved out at the end to answer any questions you have, but I'd also love to engage and continue the conversation. So if you want to reach out afterwards and chat about agentic workflows, generative AI, whatever, I'd love to expand my network and continue the conversation. All right, well, let's get into it. So a real quick agenda. If we're going to talk about agentic work, we really need to talk for a minute about the foundation, which is generative AI and large language models. So I want to spend just a few minutes highlighting some of the key attributes of generative AI and how that unlocks the future for agentic work. Then we'll talk about what's the difference between agentic and non-agentic workflows, some of the tools and patterns that those technologies use. Then we're going to talk about organizations and scaling beyond our human labor constraints, this idea of inversion of responsibility, and then a commitment to human-centric AI, and then that Q&A. So let's dive right in. So generative AI, why is this a big deal? Machine learning has been around for quite a while, and really it's been top of mind for maybe the last 10 or 15 years. And most of the early ML models that were built were very single purpose, right? Like you guys probably heard about AlphaGo beating the world's best Go players back in 2014, 2015. That model was trained just to play Go, right? It produced the very best next move you should make. It couldn't classify an image. It couldn't do anything else except play Go. And so with generative AI, it really broke the mold of having these unitaskers. Now it's really a Swiss Army knife, right? Which can handle a lot of different problem-solving issues like content creation, English to code, being able to produce, images and content. So it's a very, it's a Swiss Army knife to help solve a lot of different problems. And that's why it's a big deal over just kind of single purpose machine learning models. Contextual mastery. Anyone that used any of the early NLP tech from the 2010s, you would notice that if you could give it a few sentences of text, and you might have a chatbot that would kind of serve back and forth with you with that chat. But once you got to any sort of large context, any large amount of text, it usually lost its ability to interact in a meaningful way. And so this contextual mastery, we'll talk about context windows in a minute, but there are benchmark tests that independent testers run on large language models. One of them is called needle in a haystack, and that's where they pass in a large corpus of text and they hide a little nugget that they're going to ask about later in the follow-on question. And these generative AI models are really, really good at understanding and finding that subtlety in the context. And so it's if you're using ChatGPT, for example, you could send in compound questions, multiple questions, and it's able to track with you in a much more robust way than any prior ML models could around NLP. I think this one's greatly overlooked, but this idea that natural language interaction, right? There's a reason that ChatGPT went from 0 to 100 million users over a weekend, and it's because we all know how to interact with it. It's easy to write in our native language and communicate with an AI agent in this way. I think I'm a software engineer by trade, and I think about how software has evolved over the last 50 years. And it started out with bytecode and machine code, and then it moved to like C and C++, and then it moved to more managed languages like Java and .NET, all the way up to a bunch of no-code platforms today. Really, natural language is the highest order abstraction you can have on technology. And the ability to interact with generative AI in a natural language unlocks all kinds of potential and greatly reduces the technical need to solve problems, right? As long as you can explain what you want to do, you can solve it, and that's great. Simplified fine-tuning, the democratization of AI. Before, if you were an organization that had lots and lots of data and you wanted to create a custom AI model that solved a specific problem for your business, you had to both curate that data in a very common sense way, and you also had to bring in some data scientists to be able to set up the parameters, do the tuning of the parameters and do a bunch of training runs to get the output that you wanted. These large generative AI technologies like OpenAI and Claude and Gemini all offer a simplified fine-tuning mechanism, which is really just you taking your data and creating these prompt response pairs that allows you to coax and guide an LLM with your data set in a very easy way. Most people, if they understand the data and they're a subject matter expert, can create a fine-tuning set without requiring any developer skill, and you just need an IT person to be able to run it for you. So it's much, much easier than it used to be. What used to take months can now be done in a few hours or days. And then finally, the big deal with generative AI is this multimodality, right? When it first came out, it was text in, text out, and then it was text in and image out with like Midjourney and DALL-E, and that really revolutionized image creation and image editing. And now it's actually image and video and voice in, and then text, image, voice out. And so as those additional modalities are added, it's unlocking new use cases and widely different approaches to how you can leverage generative AI. So as a primer, that's why I think it's a big deal and why it's really taking the world by storm over the last couple of years. I do want to give a quick update too, is about the progression of what we're seeing, because where we were 2 years ago is very different than where we are at this exact moment. So one of the things that's, I think, caught some people by surprise is this expanding context window. You can think of a context window as the memory of the LLM. And so you're sending in some text, you're sending in your prompt, that takes up a certain number of tokens. It then runs through its weights and nodes, and then it outputs the tokens that are the answer, right? And so the summation of the input and the output is the total usage of your context. And when these models first started to drop in 2018, 2019, 2020, they had extremely small context windows. For reference, 1,000 tokens is approximately 8.5 by 11 piece of paper full of text. So, so in 2019, using GPT-2, you could really have a half page in and a half page out, and that was all you got. And then, really the breakthrough was in 2022 when ChatGPT dropped with GPT 3.5 Turbo. It was finally to 4,000 tokens, which gave you a few pages of text back and forth. You could maybe coax a blog post out of ChatGPT, or you could have a dialogue, but you would hear about hallucinations, and that's because the context window was still pretty small, and it would have to truncate off the early parts of the conversation to be able to keep it relevant and keep it going. Well, in 2023, OpenAI released, and they've renamed these models a bunch, but at the time it was called GPT-4 Turbo, and it had 128,000 token context window. So we went from 512 to 1024 to 4096 all the way to 128,000 basically overnight. And so that change unlocks all sorts of use cases that weren't possible in 2022 that now all of a sudden became possible in 23. And then finally this year, Gemini, Google's LLM, they released a 2 million token context window. And so for reference, that's about 2,000 pages of text. So imagine a physics textbook or a large code base or any amount of data that you want to have in memory. Now the LLM can reason over that information and not have to guess or hallucinate because it has the data there in its context window. So I only expect that to continue to grow. And it's obviously on a hockey stick curve. So we could easily see 100 million, billion token context windows in the not too distant future. Second piece that's really, really important, as you guys have probably been following NVIDIA's stock, there are no more GPUs to go get right now, right? They're all spoken for. And so this puts a lot of pressure on the large language model companies, the people that are making the frontier models, to figure out how to be more efficient, right? And so if you look at cost reduction, when GPT 3.5 first dropped at the end of 2022, it was 2 cents per 1,000 tokens, which at the time seemed pretty great considering how magical it was. Now, fast forward to 2024, and GPT-4o Mini, which is the comparable current day model, it's not their highest end model, it's their mid-tier model, but it offers a lot of similar capabilities, is now $0.00015 per 1,000 tokens, a 99% reduction in cost in just 2 years. and it has 128,000 token context window. So these software companies are building these frontier models, are working hard to make them more affordable, to expand the context window, to open up new use cases. And they're also working on capacity. So even though there are no more GPUs right now to go get, we use Azure for most of our large language model work. GPT 3.5 Turbo, we have a rate limit of 300,000 tokens per minute. With GPT 4.0, OpenAI's frontier highest performing model, we get a 10 million token per minute rate limit. So you can see they've obviously made some serious optimizations to make that happen. And that just makes it work better for users and run faster. And finally, from a generative AI perspective, there's a competitive AI ecosystem out there, right? Meta has been releasing Llama as open source, which is putting a lot of pressure on the closed source vendors to, keep their game moving, or people are going to move towards an open source approach. Gemini from Google, that large context window we talked about, they've also implemented this idea of context caching, and they were the first to release a Flash model, which is a hyper fast model that's made for real-time interactions like on your phone, where you don't and can't afford any latency. And finally, Anthropic, which is maybe less heard of, in the common area, but it has GPT 4.0 level reasoning, and they keep reducing their costs, which is applying pressure to OpenAI to keep their costs down. So the point is, it's a vibrant ecosystem. A lot is changing very, very quickly. It's the fastest I've seen technology evolve. And these changes over the past 18 months have really opened the door for this idea of the agentic workflow. And so the future is agentic. And I'll take a minute, and I'm assuming most of you know who Sam Altman is. He's the CEO of OpenAI. He was on a podcast the other day, and he was being interviewed, and he was talking about how he's in a Discord chat with a bunch of his CEO AI buddies, and they have a running betting pool about when the first solopreneur unicorn company will be in existence. And so let's unpack that. A unicorn is a company that has a valuation of greater than $1 billion, even if it's just on paper. And a solopreneur means it's a single employee company. And you think, man, working at Knowledge, I know what it takes to run a successful business and the amount of people that it requires to write code and test code and support our customers and give great customer service. And so you think about a company worth $1 billion traditionally would have hundreds, if not thousands, of employees to support that sort of market cap, right? And so the question is, well, I don't think he's crazy. He's a smart guy. How does that vision of the future align to where the technical tools are at today and where we're headed? And I believe what he's really saying is that agentic workflows and agentic workers are what are going to empower that solopreneur to be able to build a business up that could potentially have a market cap of $1 billion or more. So let's dig into this some and talk about what is agentic and what does that mean? All right, so the Knowledge Lake vision, we believe that organizations of the past were built on human capital, while the winners of the future will grow unbound by labor constraints and accelerated by the rate of innovation. Since the Industrial Revolution, technology has been improving human efficiency. And obviously today we are orders of magnitude more efficient in our daily lives than we were 500 years ago in hunter-gatherer and farming and whatnot. And technologies continue to allow us to be more and more productive. But when we look at our business, when we look at running our businesses, we still see areas where we're just not able to grow at the rate we want, right? And oftentimes that's due to I don't have enough people, or I can't find enough skilled people, or I can't afford to hire that many people to service this market. And so you either can't produce something at a high enough margin, or you can't get the right people. And so we believe, and going back to Sam's quote, that that an agentic future allow organizations to grow decoupled from their labor constraints. So let's talk about the reality of that and kind of what that means and how we're seeing that come to fruition in technology today. So let's talk about agentic versus non-agentic. So first, non-agentic, not really the right word. I would probably just call it a co-pilot. So today, let's say my VP of marketing, Bart, calls me up and says, Brad, we're running behind on content creation this week. I need you to write a blog post. Okay. Obviously, before LLMs existed, I'd have to actually do the hard work and write every word in the editor and make changes and probably work with an editor to help make sure that I was writing it correctly. But with generative AI in a non-agentic approach, I'm going to fire up ChatGPT. I'm probably going to write an outline of what I'm trying, like Bart's going to give me the subject. I'll coalesce my thoughts into a couple paragraph outline. I'm going to then feed that into the LLM, and I'm saying, hey, I need you to do this thing. I want you to write a blog post. Here's what I want you to do. I'm giving it direction. It's then going to run it through a generative AI, and then it's going to output all in one shot, zero shot, a blog post. That's pretty much fixed. And then I have to read it, and then I have to tell it, I didn't like this, but I did like that. I want you to change this. I want you to change that. We can all agree that that flow is much faster than having to write it all the old-fashioned way without generative AI. But generative AI is only going to be working at the speed that I can prompt it, right? I put in a prompt, I get a response back, and it's very task-oriented. So while that's, I believe, professionals that are using generative AI as a co-pilot are seeing 10, 20, 30, 50% productivity gains when they're using the tool, it's not a force multiplier. And so instead, if we flip that around and Bart came to me and said, Brad, I need you to write a blog post, but I also need you to write one every week from here until the end of the year. As a software engineer, I'm kind of lazy. And so I would want to take the approach of, well, how can I build a system that helps me author these blog posts in a dynamic, repeatable way that means I don't have to spend 2 hours every week working inside the IDE? How can I be a force multiplier? And that's where you think about it, building an agentic workflow. Core overarching differences is agentic workflows are going to be a system that you design ahead of time with goals and objectives. So you're going to say, the goal of this workflow is your job is to write the best technology forward blog posts for a SaaS software company. Here's the voice and style that you should be using. It should be compelling, and it should have a call to action. And you can list off these overarching goals that you're saying our blogs need to adhere to these overarching set of goals, not about the specific blog, but the overarching goals. Then I get the list from Bart of like, hey, what are the blog posts that we want to write this quarter? He gives me the list of the 12. And then we feed those 12 into the workflow. It then grabs the topics, and then it goes through that. It will design the workflow much in the same way I would have done with my co-pilot. It's all right, write the outline, do some research on the internet, come back, write the first draft, review the first draft, edit the first draft, write the second draft, then get ready to publish it to the website. And so the idea here is that you have a workflow that allows for refinement and improvement. And I can have dozens or scores of these agents working in this workflow and only asking me for help when they need it, instead of me having to sit there in front of the ChatGPT to work with it through the problem. So at a high level, non-agentic is just co-pilots or using ChatGPT or something like that. And agentic is building out a workflow that uses generative AI under the hood in an unattended fashion to solve problems with more goal-oriented approaches. Okay, so let's talk about some of the patterns and use some concrete examples to help kind of crystallize this for everybody. Okay, so the first one is reflection. In the same way that I described my back and forth with ChatGPT writing the blog post, I've written a lot of code, or I should say, I've had ChatGPT write a lot of code for me. And so I'll say, hey, I'm trying to solve this problem. Can you write this code? And it spits out some code. I then have to review it and then tell it, oh, I don't think you did this quite right, or this doesn't look good, or I don't understand what you did here. Can you fix it? So imagine instead we had a really simple agentic workflow that was doing reflection, where I have a trouble ticket comes in. We've got a defect identified in the code, and I want this agent to write the code to fix this bug. So I feed in the bug description. I feed in the stack trace. I feed in the specific code files where the bug is at. And we have a single agent, and its job, its system messages, hey, you're the best software engineer in the world. It's your job to fix bugs in this code base, produce high quality readable code. It goes in, it writes the code. And then instead of just taking that code and going, okay, we're going to ship it, you have a second agent. That agent is the reviewer agent. It's the same LLM under the hood. Its system message is just slightly different. And that message is, you are the world's most helpful code review agent. You find readability issues, you find syntax issues, you make suggestions on how to make the code more performant. And if it has any issues, you send it back. If it's good, you give it the thumbs up. And so that code gets written by the code writer agent. It gets sent to the code reviewer agent, and they iterate on that until the reviewer agent goes, yeah, we did a good job. I know personally when I'm just working with ChatGPT, sometimes I have to go back 4 or 5 times to get it right. And by having that self-reflection pattern, what we've actually found is that lesser quality LLMs can be used to produce higher quality outputs than you would get through just a single shot with the frontier models. So what I mean by that is if you were to use GPT-4o mini, which is their mid-tier model, and do self-reflection where you allow it to loop up to 5 times to work to write that code more effectively, that output will be cheaper and better than a single shot, single pass, one pass through GPT-4o. And so this reflection pattern, just like us as people, we work through a problem, we iterate and iterate and iterate. LLMs can do the exact same thing, and you can produce better quality results at lower costs through reflection, which is a great pattern. The second piece here is tool use. I'm sure you guys have seen some of the advertisements for these companies that are trying to build the bipedal robots that'll be in your house. And obviously those are going to be powered under the hood with generative AI, but they're trying to create this adapter, this interface to allow for LLMs, generative AI to be able to interface with the world. And that's true for robots, and that'll be true for self-driving cars, but it's also true for just software intensive systems, right? And so that means connecting to the world means, an LLM can accept text, it can accept video, audio, and images. That's really all it can get. And so it doesn't actually have the traditional ability to interact with other systems. And so when you think of tool use, imagine doing a Google search or querying your company's knowledge base to find the grounded, correct answers. Imagine, reading data from a database. Let's use a more concrete example around software development. So we had that code author write the code. We had the reviewer review the code. I don't know about you, but I've oftentimes looked at code in ChatGPT. It's looked correct to me. And then when I paste it into my development environment, it doesn't compile. There's a compilation error. So imagine we use tool use inside of this workflow. And at Knowledge Lake, we have a technology called robotic process automation, which allows for us to interact with the desktop and with other applications in an unattended fashion. So imagine this workflow is write the code, review the code, loop, loop, loop. The reviewer finally says, yeah, this looks good. We then create a branch in source control, and we issue a pull request. So now that code has been pushed up to the GitHub repository. Now the RPA bot is triggered, and it says, hey, I want you to go pull this code branch down to this development machine. I want you to load this up in Visual Studio or VS Code, and I want you to compile it. If it doesn't compile, I want you to grab the error messages, the stack traces, and I want you to feed that back upstream into the workflow to hand back to the coding agent to see if it can correct its mistakes. And so now LLMs traditionally don't have the ability to run code. We've now given it the ability to test the code that it's writing to make sure that it works before we ever have to get a human involved in the workflow. And that's a really powerful tool. And you're going to see tool use explode here in these agentic workflows over the next 6 to 12 months. And then finally is multi-agent collaboration. Now, we've been talking about high-level multi-agent collaboration, coder, reviewer, and then that RPA, code compilation agent. But those are on the surface really, the code reviewer and code writer are really the same LLM with the same information. It just has a different system message. But if you really have domain-specific problems you're trying to solve, you're likely going to need to take your organizational data, your enterprise know-how, and feed that into a training set to take a basic vanilla LLM and supercharge it. And the way that you do that is a handful of techniques. We talked about fine-tuning earlier, and that's where you take those prompt response pairs and build out a training set for your LLM. And that's you're going to show, like if we were doing a code writer agent, we would say, here's a requirement, or here's a bug, here's the fix. Here's a bug, here's the fix. Here's a bug, here's the fix. So it can both learn stylistically how we want it to fix bugs, and it can see a lot of concrete examples. If it's the code reviewer agent, we could go, here's a good example, here's a good example of the code, here's a bad example of the code and how you should have responded to each of these. And you can show it real concrete examples that our people created over the years, and now they can be used as a training set for your agent. Second is retrieval augmented generation. So sometimes in the workflow, you might need to do a query. Maybe I need to go find the 3 or 2 or 5 most relevant examples and feed that context in real time to my agent. So that's a great use case. That's called few shot example plus retrieval augmented generation. And then finally, getting really specific with those user unique agent profiles. If anyone's used custom GPTs in ChatGPT, that's kind of a blend of few shot examples plus hyper specialized system messages or profiles. Those together doesn't seem like much, but it can really change the behavior of an LLM to produce much higher quality outputs based on the specific problem you're wanting it to solve. So those are some of the patterns that enable agentic workflows. So I want to spend a couple minutes and talk maybe at a higher level about what this means for us and for the future. So anytime there's new technology, I think it's natural for us to be a little afraid. Like, what does this mean for me? What does this mean for my role and for my job? How is this going to impact my business? Like, what does this mean? I mean, is this good news or bad news? Do I need to be worried? And we talk about efficiency. I talked about the Industrial Revolution. It's, since technology's been around, it's been increasing our productivity, right? Excel and Lotus Notes came out 30 years ago. I don't think we have fewer accountants today than we did 30 years ago. I would bet that there are more. And so our work changes over time, but it's generally, I believe this technology to be additive for everybody. And so I'll give an example. We need to think of it about it being additive and not about, we're just doing this to take out labor expense. And so one of our customers, partners, is a service bureau that does document. They do scanning and digitization of documents, and then they extract key value pairs of entities off these documents that then get stored in the customer's repository or database or whatever. And this one partner we have has, the way that they've been doing this historically is they've got teams of people offshore, thousands and thousands of people that are doing, hand key indexing. And it works, but it's just very labor intensive, very time intensive. And they've seen their backlog of work grow and grow and grow. Their sellers are really good at selling new deals, but it's hard to find it's hard to onboard new teams to do this work. It's very detail oriented, very specific, and they just can't scale up their labor force quickly enough to work their backlog. And so this is where they need technology, not because they're necessarily going to get rid of any of those folks, but because they can't keep up with the pace of their business, and they need technology to help them scale beyond those friction points. So when you think about your business and how you're going to apply this, and we're going to talk about this more later, but like your people, your subject matter experts are squarely in the middle of these work streams. But how can we be a force multiplier to help grow your business beyond where your current friction points are and your bottlenecks for growth? Okay, the next topic is this inversion of responsibility. Today, I mentioned I sit down in front of ChatGPT and it helps me write a blog post, and that makes me 20, 30, 40, 50%, maybe 100% more productive, at least in the effort of writing that blog post. But it's consuming all of my conscious cycles as I'm working through with the LLM to solve that problem. And when you think of agentic workflows, you're really looking at a force multiplier of capacity. And so let's use the software development approach. We've got this agent that's fixing all these bugs. We're not going to ship software until it's been signed off on by our QA team. But if all of a sudden I've got an agent that can produce an output where it can fix 1,000 bugs a week, I'm probably not staffed effectively to test all of that change and get that change into production, right? And so if you imagine a scenario where I have QA agents that are writing test plans, executing test plans, and helping me get to a point where I can validate these changes more effectively. The difference here is, instead of me sitting down in front of ChatGPT and saying, hey, can you help me write a test plan for this? Instead, the agent is writing the test plan automatically and raising its hand. The agent's raising its hand when it gets stuck, when it gets confused, when there's ambiguity in what the requirements are for it to do the work. So I believe what you're going to see in the near term is that you're going to see this inversion of responsibility, where instead of humans using co-pilots to increase their productivity 10, 20, 30%, you're going to have organizations deploy, armies isn't probably the right word. It sounds too much like Skynet, but large number of AI agents that have humans sitting there doing their day job, but then answering the exception request. So it's really going to be AI agents prompting humans for help instead of the other way around. And that means that for every person you have in that work stream, you might have 10 or 20 or 50 AI agents doing the work of the business and asking your subject matter experts for help. And so that kind of inversion of responsibility is where I believe you're going to see those economies of scale that Sam Altman was talking about, helping you achieve that next rung on the ladder from a productivity perspective. And lastly, and we kind of hit on this, but this idea of commitment to human-centric AI. Look, you can't just turn your major business processes loose to an AI and go, well, it'll figure it out, it'll be fine, right? Like, you can't show up to the board meeting and go, well, this AI approved this invoice that we shouldn't have paid, and now we're out all this money, right? Like, no, you have to have governance and control and oversight into these workflows, and our people are our most valuable resource, even in this world of agentic future. We need our domain experts, human in the loop, helping guide the AI agents when they get stuck, being the gates in those workflows to make sure that we're not skipping steps and that we're following our SOP and our best patterns and practices, right? And so it's allowing our people to bring their subject matter expertise to the mix, not get stuck in the rote and mundane work, and be able to help the LLM when they need help, but really focus on their day-to-day work. Then that allows for great observability and monitoring of your processes and your workflows. And then, depending on the criticality of these agentic workflows, you might turn the dial from human always in the loop to human never in the loop, but you're only going to do that once the system's running, once you've got great observability and metrics and you know how it's performing day in, day out, week in, week out, and figuring out where you want to adjust your human capital to help keep these workflows moving effectively. So with that, I think that's a wrap on my slides. And so I wanted to pop over and answer any questions that anyone had. Let me see here. Let me look at the question list real quick and see what we got. Okay, how do you handle data security with generative AI and with large language models? This is a really interesting topic. I get a lot of questions about this. Back when ChatGPT first dropped, there was, a lot of FUD around, people were putting stuff into ChatGPT, and then OpenAI was using the data allegedly to further retrain their models, and that put a lot of CISOs and CIOs on edge. Like, well, what's my risk look like here? What's my data? Where does it live? And so for Knowledge Lake, at least, we take a very segmented approach to how we think about data. So we have a lot of security posture around never commingling client data, things like that. But we use Microsoft Azure, their Azure AI platform, for all of our generative AI components. That means that we get data segmentation, data isolation. The data is never used to retrain the models. And for us, we get to use our standard DPA that we have with Microsoft to ensure data safety and integrity. So I would recommend that you select one of the large cloud vendors. Make sure you're comfortable with the DPA and what's involved in the data privacy. But it is a fastly evolving landscape. So you got to make sure you stay on top of it. But for us, Azure is the best choice for that. Okay, let's see what else we got here. Given the non-deterministic nature of LLMs, how do your products ensure consistency between outputs of different iterations? That's a great question. So there's a few things that are important. We've built out a large testing. So for our product, when you think about intelligent document processing and intuitive AI, if we're talking about specifically documents, we create a very detailed synthetic testing set that we built with, we've synthesized data. We know what the inputs and the outputs should be. And as new models get pushed, we run those tests to validate that we're seeing continuity between current version, current version, new version. That's important. You're also things like temperature, and there are only a handful of settings you can set on LLMs, but like temperature is one, which is how much creativity do you allow in the token generation. So depending on what you're trying to do, if it's a blog post, you probably want that pretty creative. But if it's like, how much is this invoice for, you probably don't want any freestyle on that. You turn the temperature down to 0. The other thing is that we've worked hard to build out a confidence score, and so we have the ability to produce a confidence threshold that maps to the corrected data before. So we have ROC curves, and we can measure, okay, this confidence interval should produce accuracy rates at this level, and we're comparing to make sure those ROC curves look the same from version to version. And then obviously our customers can also generate those based on the output to adjust the sensitivity that they want to have for human review of the data. So certainly emerging patterns there, but testing, and there's no replacement for good old-fashioned testing and making sure that from A to B things didn't change. So next one is, where do you see generative AI going over the next 6 to 12 months? I think what we're seeing, we talked about context window, and we talked about performance, the rate limit, and cost. They're going to continue to push the envelope in those areas. Again, as I said, there are not many GPUs on the market that you can go get. So these cloud providers are really focused on figuring out how to reduce their inference cost so that they can run tokens through more quickly and expand to additional use cases. I think what we're also seeing is we're seeing smaller models come out. So they're working to cut out a lot of the cost to train these models as well, because that takes up a ton of GPU time. And so finding the way to make the models smaller makes them easier to train, faster to run, and it's just, in general, the limitation right now is compute. Obviously, you have companies like OpenAI. Sam Altman talks about AGI all the time. I think that, I guess we'll see, right? When you talk about exponential growth, if we think we're halfway there, it means the next iteration is we're all the way there. But I think that they're still making a large investment in that. But I don't think we're within the 12-month window of seeing anything that has, AGI hallmarks. But certainly those vendors are trying. OpenAI and Google are trying to go that direction. I just think it's a ways off. All right, I think that might be it for the questions. Does anybody have anything else they want to drop in there before we move on? Okay, well, to wrap up here, we have 5 spots available for a no-charge proof of concept to help get you going on your AI journey. 3 ways that you can take advantage of this POC. You can use the QR code here and fill out the form. I believe there's a URL in the attachments section, or you can shoot an email to Rachel, rachel.gillespie@knowledgelake.com, and we'd be happy to get you going on your AI journey. I'll leave that up there for 1 second, just to make sure everybody gets a chance for the QR code. And with that, it's a wrap. So appreciate everybody joining today. Please feel free to reach out, and I'd be happy to, happy to engage with additional dialogue and conversation. So thanks so much, everybody. Have a great rest of your day.